So this is the HMC 5883L, a triple axis magnetometer sensor from Quartz Components. So this sensor can basically be used to find the geographic north. It is mostly used in digital compass and also in robotics if you want to tell your robot in which direction to go. So let's see how to use this sensor. Now, by taking a closer look of the sensor, you can see that the main sensor, HMC 5883L, is in the middle over here, surrounded by a lot of jelly bean passive components. One other component which you can recognize is the voltage regulator over here. Now, if we turn it on the back side, you can see that the sensor module has actually 5 pins. The first pin is the VCC, which is used to power the sensor up to 5 volts. The second is a ground. Then we have the SCL and SDA pins for I2C communication. Then the DRDY pin is used for changing the frequency, which is mostly not used in many projects. So the pins that we'll use is VCC, ground, SCL and SDA. So one more important thing which you should realize is, if you see on the top of the module, it is written as HMC 5883L, but if you take a closer look on the IC, I'm not sure if you're able to read it. It will be written as QMC 5883L. So yes, the HMC is actually the original name, but most of the modules which is available in the market has the QMC 5883L IC. Both the ICs have almost the same functionality, but you have to know that it is a QMC, it's a Chinese clone, it has the QMC IC, and you need to use the respective library for that. Now let's quickly connect this to Arduino and see how we can read the values out of it. So this is our testing hardware. As you can see, we have our HMC 5883L 3-axis magnetometer IC over here, the module over here, and then we have an Arduino Nano, a 16x2 LCD display, and an I2C display driver over here. So all of these are purchased from Quartz Components, and the connections for these can be seen over here. The circuit is very simple. We have powered the module using the 5 volt and ground from Arduino Nano. Then we have used the SCA and SDL pin to the I2C pin, which is A4 and A5. The same pin is also connected to the SDA and SCL of our LCD display driver module over here. And then we have powered everything with the 5 volt from the Arduino Nano. So instead of using I2C module, you can also directly connect the 16x2 LCD with the Arduino. We have used an I2C module so that the connections look neat. Now, we have already uploaded the code on the Arduino Nano for testing this project. I'm not going to explain the code or how to add the library. All of that is already done in the documentation. You can click on the link in the description to read the complete blog if you want to know how the code should be uploaded. So that being done, let me power the Arduino Nano and I will show you how this magnetometer is able to detect the north. This is a compass printout. You can detect the north pole, and as I rotate, you can see that the degree on the LCD will also change. Okay, here we have powered the device. You can see this is the 90 degree and the sensor is facing 90 degree, and the value displayed here is somewhere close to 90 degree. So it's not very accurate. Even a tiny movement will change the results, and you can consider a 20 degree error. So, but if I move this, you can see that from here it's 90, 100. So the sensor is pointing 90 degrees now. If I move it, you can see that the value is also increasing. And if I go all the way over here to the south, you can see that the value is almost close to 180 degrees. So 180 degrees here. So when it is facing the south, it shows 180 degrees. Now if I come back, it shows 90 degrees again. So similarly, you can do a full circle and know which direction your robot is facing, or build a compass to know which direction is north and which direction is south. So that is it, guys. This is a very simple but interesting magnetometer sensor which you can use. Thanks for watching. Have a nice day.